Excuse me, sir.
Yes, you are excused.
Will you assist me to solve this mathematical problem?
Which problem do you have, Melly?
Convert to fraction 0.12762.
Melly, I'm writing. You're saying I convert what?
0.12
0.12
762.
762,
A dot on top of 7.
a dot on top of 7,
And the last digit 2.
and this last digit 2. That's simple. But again, you realize that now we have a dot on top of 7 and a dot on top of 2. What that means is that the last 3 digits, that is 762, is recurring. And therefore, we'll start by having R is 0.12762 until the world come to the end, because it is recurring. 10R will be, you just take this decimal point to the right by one step. We will have that now being 1.2762762, the many number of times you can write that. So at every step, we'll check whether the number after the decimal is the same, so that we obtain 0 on the decimal side. This being 1 and this being 2, we will proceed to 100R being 12.762762, and so on and so forth. So we have here 1, 2, 3. There is no similarity in the number after the decimal point. We proceed to 1000R. Again, we shift that. That will be 127.62762, and so on and so forth. Again, we can check 1, 2, 7, 6. No similarity yet. We move to 10,000. R being 1276.2 762. We have 1276.2. Now you can see there's a similarity that exists here and here. We will compare those two. Why? Because the number after the decimal on the row of 10,000R is 2, and that on row of 10R is 2. That is the similarity I'm talking about. So we shall have 10,000R minus 10R is equivalent to, of course, the decimal side you'll get 0. So we'll just have the whole number part. That will be 1276 minus 1. 10,000R minus 10R gives us 9,990R is equivalent to 1276 minus 1 gives us 1275. We'll have to take this now, if you allow me. I bring that up there. That now means I'll be having 9,990R equivalent to 1275. We divide both sides by 990, divided by 990. Of course, this side we have R alone, but the other side we have 1275 over 9,990. Not yet at the solution stage, because you realize that all fractions must be simplified. So we begin the journey of simplifying this fraction. That is where the divisibility test now comes in. A number is said to be divisible by 5 if it ends with either 5 or 0. That means that 5 can go here. How many times? Can somebody have, into 12, we have there 2. Remember 2, 27, we have 5. Remember 2, that is 5, 255. Down here, it goes there how many times? 5 goes there 1. Remember 4, that is 9. Remember 4, that is 9. and that is it 8? I think that is 8. So we have 255 over 1998. 5 can no longer go into the denominator, so we cannot use 5 to simplify. Further, we invoke another divisibility test. Number is said to be divisible by 3 if the sum of the digits is a product of 3 or is a multiple of 3. Let's confirm if that is true for the two numbers we have here. So I have 2 plus 5 gives me 7. 7 plus 5 gives me 12. That means this number is divisible by 3. Down here, 1 plus 9 is 10, plus 9 is 19, plus 8, 27. 3 can also go into the denominator. It goes here, therefore, how many times? I see 85. It goes there how many times? Is that not 6, 6, and 6? This is the answer. Are you assisted, Melly?
Indeed, you are the only sir in East, Central, and West of Africa.
Thank you, Melly.